All right, let's get started. Hey folks, I'm here to talk about our reasoning models, such as the latest R1, O3, or O3 mini, I guess, whether or not they're better as LLM judges. So I recently gave this talk at the AI Engineer Summit in New York. As you see, there's a lot of interest, but it wasn't recorded. So I figured I'd record this for all of you and post it online together with the links. Many folks asked for the links, but here's the whole deck and what I tried to test and prove. So first of all, a little bit about myself. My name is Alex Volkov. I'm an AI evangelist with Weights and Biases. And my main focus is on LLM evaluations and agent evaluations for WNB Weave, our LLM observability and evaluation framework. I'm also on X. Some of you may know me from X. I'm the host of Thursday AI News, which is a weekly AI show about everything that happened in the week of AI. We go live every week on X, but we also have a YouTube channel and a Spotify. All of them you can find in this Thursday.news link, or if you scan this QR code. And because I'm focused on LLM evaluations, I was very interested in figuring out whether or not the recent crop of reasoning models is better as LLM as a judge for evaluations. But before this, for those of you who have no idea what I'm talking about in terms of evaluations, let's do a quick evaluations primer. Developing AI applications is different than developing standard software engineering. And the reason is these models are non-deterministic in production. And so in order to know whether or not they're working correctly, the best way that the industry found is called LLM evaluations. Here's a basic intro to an evaluation. We take a data set of some samples. Those samples include an input. Think of it like a question for your LLM, maybe from production, maybe something you wrote ahead of time. They include an output from your LLM. So if you want to compare, let's say, your production model, let's say use GPT-4o, to something like an O1, you would start generating the same answers with a new model, and then you need to somehow compare them. And oftentimes, those data sets include a golden answer or criteria for judging. So sometimes, if you're very lucky, you have the exact answer you would like your LLM to answer. Oftentimes, when you summarize 17 pages of a PDF and the result is a 3-page output from the LLM, golden answer, an exact answer is not what you want. You want actually the intelligence of these models to come through. So often you would add a criteria for judging, a list of rules by which an answer would be good or not. Okay. So on this evaluation dataset, you then go and you generate your production LLM or the LLM you want to compare to your production LLM. Let's say you fine tune or a new model. You generate answers to these questions, and then you do something called scoring or grading. Those can be numeric, those can be Boolean, those can be a range of numbers, etc. There's different ways to generate a score, but it's very important for you to have something that's empirical so you can compare. And the industry basically set on 3 main ways of scoring an LLM app evaluation. The first one is programmatic evaluation. It's the most similar one to unit tests, the most scalable one, the one you can run with code, does not have intelligence, and is by far the most cheap one. So examples for when you would use a programmatic evaluation scoring would be when you have numerical output, you want to just compare, is 7 equals 7, or 7 is higher than 5, etc. Or if you have a code generating app and you want to test it out, you want to maybe programmatically evaluate whether or not the code compiles, does it have syntax errors, etc. Assertions. For example, when you want to make sure that your model doesn't include the name of your competitor, assertions are a great way to programmatically evaluate whether or not your model has regressed in production. And also, lately for agents, for example, tool use, right? So making sure that the models responded with the tools that you actually have access to and they didn't hallucinate, that's a great programmatic evaluation setup. The other evaluation scoring grading method is the best one, but the most expensive one. It's called human in the loop. If you folks are familiar with Scale AI, that's a lot of what they do. But honestly, that's what all of us do when we test our applications in production. By far the best. It fits subject matter experts the most, but it's hard to scale and it's very expensive. And the one that we're excited about and the one we're here to talk about is LLM as a judge. LLM as a judge, we found out, with some exceptions, that they're great at judging, and they're the most scalable because they do actually have intelligence. So unlike programmatic, they understand what they're reading and judging, what the task is, but they need iteration, they have a bunch of biases. I will do an honorable mention here for eval vibes. Eval vibes is very important. Many people actually, that's how they run vibes on evals. The problem with vibes evals, I'm going to go like this, is you cannot be empirically correct about vibes evals. You cannot do math and subtract the vibes of today and say, oh, today the vibes are 7, yesterday the vibes are 2. So you cannot actually be empirical with vibes. You can generally know whether or not the application works or not, but it's not enough. We need empirical data. Before my hypothesis, I noticed the rise of thinking tags. You probably have seen these tags. This is the plot from O1 Mini, where they showed that test time compute is a paradigm that scales. The more it scales compute, the better the answers are in specific areas, like AIME, competition math. And these models have been trained with verifiable outcomes with reinforcement learning, and they become significantly better with math and code. And they have been recently everywhere, including R1, O1, O3 Mini came out. Hopefully we'll get O3 at some point, but it looks like it's just going to be rolled into GPT-5, and Gemini thinking as well. And I started wondering, then doing some research on whether or not these new thinking capabilities actually improve these models as LLM as a judge. Here's my hypothesis. Intuitively, the better model are overall, the better they are performing judging tasks. That's intuitive hypothesis, okay? In addition, because we can scale the reasoning, we can hopefully have better judgment, while our production models can remain fast and cheap. Judgment, most of the time, our evals can run offline, and so we can actually lean into this test time compute and maybe spend some more money on judging tasks. Additionally, every time I create LLM as a judge prompt, I ask it to output its thinking. I think it's the best practice in LLM as a judge. You don't actually use it as judgment, but you actually ask it to output its thinking. This helps you debug the judge process of thinking itself. And many of these models return the chain of thought that's built into them. So Gemini thinking does, hopefully Grok API when it comes will return the thinking. And oftentimes this leads you to better debugging of a model. And because these models are thinking and have chain of thought built in, they can self-correct. They could lead to a better judgment. That's the hypothesis, okay? What are we actually looking to improve? What is the issues with LLM as a judge? Well, LLM as a judge, they have documented biases and problems, and these are just some of them. There's a few, I think a few more. I added these from this research, a survey on LLM as a judge, but they're very documented. And I'll add all the links at the end with the show, with the recording. So, for example, there's the position bias. Simply put, some LLMs prefer the first or the last answer when given an array of different answers to kind of to grade between. They just prefer the first or the last one. There's the verbosity bias, an interesting one, where models just overvalue longer responses. They tend to prefer longer responses, not the most correct ones, when they are asked to judge between two. Numerical preference, some models like the number 7. For some reason, as judges, they like the number 7. So if you present them like, I don't know, A, B, C, D, F questions, they would go for F or number 7 or etc. So sometimes they have numerical preference. And my favorite one is nepotism bias. It's very interesting, but folks found out that LLMs prefer to send outputs from their own family. For example, GPT-4 outputs, GPT-4 judges will prefer GPT-4 outputs. Claude judges will prefer Claude output. So oftentimes the best advice is to just switch between them. So you would judge GPT-4 outputs with a Anthropic judge, for example. So these are the things we're looking to improve, these biases. And the most important thing I would like you to take from this talk is this very simple thing. Higher eval scores on LLM as a judge does not mean a better judge. If you like to test whether or not a better model for your application works in production against your existing model, you cannot just like string replace the model. You cannot put the O3 mini model instead of GPT-4o and just expect everything to work. This model is a thinking model. It takes longer, but it also requires different prompting. For example, you would use an evaluation, right? For judges, the same thing is happening. If you take one thing from this conversation is that a higher score does not mean a better judge. It just can mean that the judge is more biased, okay? So we need to do something called meta evaluation. We're basically going to evaluate our judges. And here's an example of something that happened to me. I actually tested on my data set 2 judges. One of them was 4.0, and then I used an O1 judge, LLM as a judge. And then I noticed here that you can see that the red one, it was the O1 judge, which is the reasoning thinking judge. It took me way longer and cost me much more, but it got 96%. This is Weave, the weights and biases dashboard for evaluation. And then my GPT-4 judge was 88%. So I was like, okay, this is a better judge. But then looking at something like a correlation, I noticed that it's not really true. The judge is not really better when compared with human experts using something called Cohen's kappa. Cohen's kappa is a correlation metric with inter-rater alignment. So alignment between our judges and human in the loop, or human graded answers, for example. So one thing very important, as you see, there's no difference in the judging quality, but it is a difference in the judging score. So if you are interested in the topic of meta evaluation, a good friend of mine, Eugene Yan, is probably one of the world's leading experts. He did like great analysis on this, and he has a way to decide kind of correlation metrics to use when. And I would definitely refer you there, because that's where I learned a bunch of the stuff that I'm talking about. Correlation metrics like Cohen's kappa or Spearman's rho and Kendall's tau. And Eugene has a quick go-to of how to decide when to use which when you're evaluating evaluators, i.e. meta evaluation. All right, so let's go into some findings. So I did actually do some research into this. And for example, for tasks like math and code tasks, LLMs as judges are potentially better. We found this as well. Reasoners are much better at math and code just generally because they were trained with verifiable outputs on verifiable domains with reinforcement learning. Code and math specifically, those models are significantly better at code and math. This means they can solve the issue in the prompt before the judging itself, right? So you would ask the judge to, hey, here's a task that my production model got in the math or code areas, and the model is very good, so it'd be able to just like solve the issue for you, which is great. They can often potentially overcome the fallacy oversight bias, where non-reasoners may not be able to, and just kind of the issue, and not only see the outcome and just like see the thinking as well. On creative writing, a very interesting result from Sam Peach and EQBench found that they built a benchmark called JudgeMark, which tests LLM judges on creative writing evals. It's a triple threat of difficult tasks, which is evaluating writing quality, effectively using multi-criteria for numeric scoring system, and following complex instructions over a long prompt. So Sam conducted a bunch of experiments and shows that for creative tasks, reasoners tend to overthink the problem, causing the score for this task to hurt performance, not actually become as good as non-reasoner models, but actually hurt performance and become worse. So very interesting result from EQBench and JudgeBench, which is created to evaluate LLM judges on tasks where crowdsources human preference is a poor indicator of factual logical correctness. Again, this is a task that was built for LLM judges. Simply said, these tasks are hard for LLMs to do. Even GPT-4 gets just a little above random 50-50 chance. On this benchmark, though not complete yet for R1 from DeepSeek or O3 for OpenAI, because they didn't release an API, even O1 preview here shows a significant improvement over the best non-reasoning competitor, Claude Sonnet 3.5. So on the JudgeBench tasks, the reasoners are actually topping the chart. Since then, Claude 3.7 was released with thinking, so I'm eagerly looking forward for JudgeBench to actually retry some of these newer models that we got. But at the time of my research, reasoners already were topping the charts by significant margin as well. So you can see 64 to 75 jump, almost 10 points. So this is a significant response. So definitely state of the art on judging. Another meta-analysis called a survey on LLM as a judge found no clear advantage. Right, so they actually, this is a quote from them. Reasoning-focused LLM failed to exhibit a clear advantage in tasks requiring alignment with human preference. And another additional context, I found out about this result from the folks at Writer. Have tested the reasoners against their own fine-tuned model called Palmyra, but also the basic model. This is not LLM as a judge task specifically. This is just a specific task that they found in financial QA, I believe, and they called it fail-safe QA. They noticed that reasoners perform worse than fine-tuned models on context adherence than non-reasoning models. So you can see thinking models are around the 60s and 59s. And they did measure orthomania in 01. Again, not an LLM as a judge task, but it shows that reasoning does not just 100% mean better at any task generally. There are downsides to reasoning as well. Here's the answer. Maybe not the answer we're looking for, but the answer when you ask a senior software engineer about anything is always, it depends, right? So reasoners are great at topics with verifiable outcomes, STEM topics, math and code. They're not that great at creative writing. This is the lay of the land right now. Earlier models are topping JudgeBench, which is a judge. And I think a lot of it is because JudgeBench does include math and code reasoning task, math and code task in there. Reasoners are also more expensive to run, and they run for significantly longer. So this rules out kind of online evaluation or guardrail use for using reasoners as judges, right? Models like R1 or Gemini thinking traces, you even get a glimpse to the judging itself. So great for debugging, better for debugging. Otherwise, you would just need to use to ask the judge for thinking processes, like the standard, hey, show me the chain of thought. Yeah, take a look. Another thing that I found out while I was preparing this talk is there is a possibility to get to level of the reasoners without using reasoners, something called verdicts from the great folks at Hazelabs. They introduced a LLM as a judge framework, and they introduced something called judge time scaling. So unlike test time scaling or test time compute, are offering a library. They're getting state-of-the-art or near SOTA results on this expert QA judge tasks. Okay, you can see here that on this one, GPT-4 01 absolutely crushes this, but also is very expensive. They beat 01 with 79 or so percent by costing a third less, so around $51 versus 150 or so. This is an attempt to try and compose judge panels together from non-reasoning models to match reasoning model level, even on math. So this has a latency of smaller models at a third of the cost, and definitely a very interesting attempt. And shout out to folks from Hazelabs about Verdict, and you guys should definitely give this a try. So interesting thing, since I started preparing this talk and doing the research, I noticed that Grok 3 came out, and then Cloud Sonnet 3.7 came out. And here you see it says Anthropic Rumored Unified Model. They actually released the model. It's called Cloud 3.7. And since I started like this research, we noticed that the AI world moves incredibly fast. And so because of this, the question may not matter soon. This question may resolve itself because models are converging towards unified models that have reasoning when they need to, and the models may decide themselves whether or not to turn on reasoning. Grok 3 launched since I started writing the slides. OpenAI Roadmap announced that O3 won't be standalone. It will come with part of GPT-5. GPT 4.5 is not a unified model. This is my slide that I predicted it would be. No, it came out and it's just like a large model. It's not reasoning at all. Anthropic has a rumored unified model, and Cloud Thinking came out with 3.7. So you can choose which thinking to turn on, right? So the AI world moves incredibly fast, and we may not have this problem that I set out to figure out. Okay, the one thing I will leave you here is how do we build reliable agents and RAG solutions when everything moves this fast? Well, we do evaluate. Remember this GIF? But in our case, we need to also meta-evaluate. We do this at Weights and Biases. So this is our product called Weights and Biases Weave, which is the best in the world at this exact tasks. And if anything that I just covered piques your interest of how to evaluate or meta-evaluate, just reach out to me everywhere, and we're at different conferences. We're talking about evaluation all the time. If you have anything to correct me with or some research that I haven't seen, I would love to see this as well. We offer an LLM observability and evaluation frameworks. We offer scorers for evaluations as well. We offer offline evaluation and soon online evaluation and guardrails as well. And we're always interested in learning as much as possible, as much as you, into the area of LLM evaluation, agent evaluation, and RAG applications evaluation as well. So thank you so much. If you talk was given at a conference, so I would say come visit us at our booth, but definitely give Weave a follow. So WSH/Weave or pip install Weave, just give it a try. But also follow me on X and YouTube for slides and links and all of the stuff above, or scan this QR code. Thank you. I hope this was helpful. Bye-bye. Oh, and every Thursday we're doing a podcast, so come join the podcast as well. Bye.